Now we will solve a truss problem using the method of joint. So here I am showing a very basic problem of truss where we have to identify the forces in different members. Here it is mentioned that we have to identify the forces at joint E. However, if we want to solve problem for all the members, we can solve this problem. So if we will see the truss carefully, we can observe that there are two supports A and D, where A is showing as a pin joint and D is showing as a roller joint. There are two forces acting at point B and C of magnitude 100 Newton and 200 Newton, and all the interior angles are of 60 degree. Now before I start, let me tell you two important things which we are going to follow throughout the solving the problem. That when we represent the force in a member, suppose this is a member of your truss, and if I am showing force in this way, that means this is the internal force of this member, and the internal force arrow if showing in this way, that means the forces are of tensile nature. We have already discussed this part in our other video, where how these arrows will go inside or outside based on the nature of the forces. So here I am not explaining that part, but we should remember that if the arrows are moving in this way, that means the nature of force is the tensile, and if the arrows are going in this way, that means the nature of force will be compressive. Second part, when we are making free body diagram of any of the point, and if I am making a force going in this way, that means the nature of the force will be tensile. Because if this is the point and I am making the free body diagram of this point, that means, and I am representing this force, so the arrow is going away from the node. However, when we see the complete member, the two arrows are coming to each other. So this is the tensile nature. Or if I am making a free body diagram of a point and I am showing any force coming towards the node, that means the nature of the force will be compressive. Now the second important concept is that whenever we want to solve a truss, we are basically going to write the equation for the equilibrium of a particle or a point. And we know that when it is a two-dimensional problem, and when we are having a equilibrium of a particle and when we are writing the equation, we know that we can solve maximum two unknowns, because when there are number of forces acting on a point, we are basically going to write the summation of horizontal forces and summation of the vertical forces. So basically we are having two equations and maximum two unknown can be solved. Therefore, whenever we will start solving problem of trusses, it is very important to consider or start the problem with a joint where we are having maximum two unknowns. So now there are two rules. That one, we can start from a point where maximum two unknowns. Second one, in my solution, basically I am going to consider all the unknown forces as tensile force, and then when I will solve the problem, if my answer will be negative, that means the force direction is opposite. How otherwise, if my answer will be positive, the force direction will consider as tensile. So this is the truss of our problem. So the first job will be to make the free body diagram of each individual point. So here I am showing the free body diagram of my members. I am showing this is the diagram of my truss, and here I am showing point A. These are point A, B, C, D and E. So this is my point A, and I know that there are two members as well as this is a pin joint. So I am going to make two reaction at the pin joint and two forces. One is force along AB member, one force along AE member. And as I have already said that these are two unknown forces for me. So it is irrespective that I am taking the force of compressive nature or tensile nature, when I will solve the problem, the answer will tell me the actual direction of the force. So normally whenever we take a joint, we consider the force as of tensile nature. Here also I am taking the forces away from the joint, that means the nature of the force will be of tensile nature. This is my second joint B. Here there will be three members, one which will be BA, one member which will be along BC, and one member which is going along BE. So here also I am taking all the three forces away from the joint. So this will be my force AB, this will be my force BC, and this will be my force FBE. Here also I am taking 3 members. So now again all the forces going away, CD, FBC and FEC. This is also all the forces away. Why I am taking all the forces away? Because when you will consider only one kind of convention, it will be easy for you to solve the problem every time. Generally, I am generalizing it that every time you can take a tensile force, and when you will solve, if the answer is negative, it is the compressive force, otherwise it will be a tensile force. So this will be force ED, this will be force AE, this will be force EC, and this will be force BE. Here is the D joint. D joint is a roller joint, so there will be only one reaction. I am assuming the reaction which is dy, upward direction. This is my force FCD, and this is my force FED. So now I am having 1, 2, 3, 4, 5 points, and the free body diagram of 5 points are available. And my first rule said that whenever you are having find a joint where maximum 2 unknowns. This is my condition. So if I look carefully here, that from which point I can start my problem. So here I have 3 forces, here I am having 3, here I am having 4, and here I am having 1, 2, 3, 4. So is there any point available in the system where only 2 unknowns? Here also, here I am having the force of 100 Newton, as well as here I am having a force of 200 Newton. So if I carefully look, all the forces are unknown. Here these AY, AX is unknown, both the forces are also unknown. So if I look carefully, there is not a single point available where only 2 unknowns are there. That means first I have to create a point where the 2 unknowns will be there, and that I can do if I will take the reaction, or I will calculate the reaction at these 2 points. So to calculate the reaction, first we have to take the complete truss as a single body, and we can calculate the reaction. Here I am showing the reaction, that this is my complete truss, here are my 2 reactions, and now I am not bothering the forces at every joint. The complete system is a single body, and which is subjected to 2 forces, 100 Newton and 200 Newton, as well as the 3 reaction. So when I will take the moment at point A, here will be my reaction, that 100 will be, this distance is 2. So this will going this way, so 100 into 1, 200 is going from this way, so 2 plus 1, 200 into 3, and EY will be 4. So 100 into 1, 200 into 3, minus, this is my basically dy force, not the EY force. So dy into 4, and from solving this equation, I am getting that the vertical reaction at point D is 175, and I know that total downward force is 300, so remaining reaction will be 125, and since there is no other horizontal force, AX will be 0. So now I have calculated my reaction. So when I will go back to the free body diagram of my points, now in this free body diagram, this is 175, this is 125, and this is 0. So now I have 2 points from where I can start. One is the point D, one is the point A. If I will start from point A, these 2 unknowns can be calculated. Once I will calculated any of these 2 unknowns from on this side or this side, then I can move further. So once I will solve this joint, I will be able to know these 2 values, then I can move here or here. So let's see, if I will move here, again there will be 3 unknowns. So no, I cannot come here, because I can take a joint where there will be only 2 unknowns, maximum 2 unknowns. So when I will calculate the first joint, I will know FAB. When I will reach to this joint, this is known value for me, and these 2 will be unknown, so I will be able to solve these 2, and this way we can consider all the joint, and we can calculate all the unknown values. So let's start with joint A. Here I am showing the free body diagram of my joint A. This is the joint A, and I am saying that this is my So this is my joint A, and I am having force AE and force AB, and joint AY, which is having a reaction 125. So now once I have the free body diagram of a point, the next job will be to write the equation for the horizontal forces balance as well as the vertical force balance. So when I will balance the horizontal force, the horizontal component of FAB will be sum with the AE. So FAE, since this is my positive X direction and this is my positive direction, so FAE plus FAB cos 60 will be 0. When I will write the vertical force balance, FAB sin 60 plus AY will be 0. So when I will solve these two equations, I am getting that FAB is coming out minus 250 by root 3 and FA is coming out plus 125 by root 3. That means the negative sign is showing that the actual nature of this force will not be tensile, or it will and actually it will be a compressive force. However, the second force is coming positive. That means the nature of the force will be tensile. But once we have considered the forces, we are not going to change the direction throughout the problem. At the end, we will define all the forces that this force will be compressive and this force will be tensile. So once I will finish with joint A, now I know these two unknowns. So now I know these two unknowns, I can move to joint B here, because at B this is known value, this is known value, and there are only two unknowns. Or I can start from here, I can calculate these two forces and then I can move here. So it is up to you that from which direction you want to move. I am solving from here to here and here, and I can move towards all the point and I can calculate all the unknown values. So when I will consider my second joint, that is my joint B. Here is my joint B, and joint B having three forces, AB, BE and BC. So this is my BC force, this is my BE force, and this is my AB force, which is known. And I am taking the direction away as well as I am taking the negative sign. Please keep it in mind. Here you are assuming the force is tensile because initially you have already considered all the directions, but you calculated the force and you found that the amplitude of force is negative. So you will consider the force negative throughout the problem, but you know actually the force is compressive. So here also I am taking the force as minus 250 by root 3. This is 100 and these are two unknowns. So again here I will write the force balance in the horizontal direction and the vertical direction. Here I am writing for the vertical first. So when I will solve the vertical direction, I am getting that my BE force is coming 50 by root 3 because the 100 will be in the downward side. Vertical component of AB as well as vertical component of BC will also be in the downward side. So I am putting negative sign for all the three. But actually when I will put the value of this AB, which is minus 250, it will basically a positive sign. And finally after calculating the equation, I am getting that B is coming out 50 by root 3. Then when I will balance the horizontal forces, the BC and BE cos 60 will be positive and AB cos 60 will be negative. Again I will put this value which is the negative sign, so finally it will be a positive sign, and when I will solve, I am getting that BC is coming out minus 150 by root 3. So this BC is of negative sign, means compressive. B is coming out positive signs, means it is tensile. Now I have two choice. I can move here or I can move here. When I will come here, I know that these two will be known and these two will be unknown. If I will go here, there will be these two will be known and these two will be unknown. So now let's see that we have choice. We can solve any of the two joints. So I am showing here that the free body diagram of joint C as well as the free body diagram of joint E. But I am considering joint E because I know that when I will solve this joint, it will be easy for me to get the unknown values. But it is up to you that which joint you are taking, because the equations are simple and you can solve considering any of the joint. I started with joint E. There are four forces. Out of these four forces, the BE is known to me, which is positive 50 by root 3, and AE is also a positive 125 by root 3, and EC and ED are unknown. You can see here that basically I am considering joint E. There are four members. Here is the free body diagram of joint E, and this is the same diagram. But I know these two values which I have calculated in the previous step. Again I will write the horizontal and vertical force balance, and from these I am getting the unknown values of EC, which is coming out 50 by root 3, and AE is coming out 125 by root 3. So now this ED is also coming out 125 by root 3, and this EC is coming out 50 by root 3. So if I will see now, I have most of the force I have calculated. I have calculated these three forces. I have calculated these four forces. So now which unknown left? Only the force CD and ED are unknown to me. So now I can take these joint. ED also calculated here. So only the FCD is unknown to me. So either I can solve this joint or I can solve these joints to get the value of CD. I am taking the joint D to solve the problem. So this is the free body diagram of my joint D, where ED is known to me, only the CD is unknown. So when I will take the vertical force balance, I will be able to get the force of CD. So this is coming out minus 350 by root 3. So now I have calculated all the forces, and the final job is to just represent all the forces on my truss diagram. So here is my You can see I have shown all my truss again here, and here are the list of the forces. Here you can see that I have shown the diagram with negative signs, but basically you can write that this force will be of compressive nature, and I know that AB is compressive nature. Here is the AB, so here I will show the actual sign that if the forces are compressive, the arrow will go in this way because this is the internal force. If BC is of negative sign, so this BC is also going this way, and the magnitude is 150 by root 3. This magnitude is minus 250. So I am not going to put this minus sign now because I know that this nature of force is compressive. This is also my compressive force. CD is also negative, CD here, and it is coming out 350 by root 3. Here also it is of compressive. Now force DE is here, and it is of tensile nature. That means arrow will be showing in this way, 125 by root 3, and the force nature is tensile. A is also 125 by root 3 of tensile nature. BE is 50 by root 3 and tensile nature. 50 by root 3 tensile nature. Similarly, EC is also tensile nature, going away from the node. This is of tensile nature, so it will be this way. Sorry. This is also tensile nature, 50 by root 3. So finally I have calculated all the forces in my trusses, and I am representing that this is my AY and this is my DY, which is 175 and this is 125. So this is the complete solution of my truss where I have calculated all the forces. Now let's see the second problem. In the second problem I have taken a problem of cantilevered beam, cantilever truss. Here you can see that there are members, and members are connected with a vertical wall, and both the joints are pin joint here. We have seen in our previous video that these joints are basically both the joints are pin joint, and that basically considered because we want to solve a problem, or the truss should be designed as to be stable. So when we calculate the stability of truss, we observe that if both the joints should be of pin joint, but here I am not going to discuss anything about the stability of the truss. We have to simply find the forces in different member of our truss. So now again the same problem, same thing, that what is the first rule? The first rule says that find a joint where you are having maximum 2 unknown. In this case, if I will look carefully, I know that these two are the pin joints, so there will be 2 reaction. Here also there will be 2 reaction. So if I will consider this joint, the 4 are unknown value. Here if I will see these 3 are unknown value, 1 known value. Here these 4 are unknown value. But if I will see the joint C, at joint C I know 1 force and 2 unknown. So in this case, whenever you are having a cantilevered problem, and if you are able to identify a joint where you are having maximum 2 unknowns, you can start your problem. So now again I have to make the free body diagram of all the point, and we know there are one point which is A, this is second point which is B, this is third point which is C, the fourth point is E, and the fifth point is D. And now let's make the free body diagram of all the points. Here the joint is a pin joint, so there will be 2 reaction. I am assuming direction that may be correct or incorrect, but when I will solve the problem, if my answer is positive, the direction I have considered is right, otherwise the direction will be opposite. Here also I am taking the 2 direction, and I am assuming both vertically upward and the rightward. As the joint B is having 1 force which is coming out downward direction, which is 100, there are 3 members. And as I know that I consider the force of tensile nature, and when I will solve the problem, if my answer is positive, that means the direction considered is correct, otherwise I have to change the direction. Here are 2 forces, one FAB and FAD. Here also there will be 4 force, one FBD. Similarly here FBD, 1 force will move here, that will be FCD. 1 force will be here, this will be FED, this will be ED, this member will be FAD. If I'll start from here, I'll see that this member will be FBC, this will be FCD, and there will be force of 200. and here one force will be of 60. So here I have considered all the forces. If you will see here, there will be 1 2 3 4 5, 1 2 3 4 5, here 1 2 3, 1 2 3, 1 2 3 and 4, 1 2 3 and 4, 1 2 and 3 4 2 reactions. So 1 2 3 4. Here also I am having 1 and 2 3. So 1 2 3. So now here you can see that I have made free body diagram of all the points, and if I'll see carefully, I have a point from where I can start my problem. So as we have seen in the previous case, we could not find any point from where we can start, so we calculated the reaction first and then we started the problem. But if you will see here we have a choice, or we can take directly point C as my starting point, and when I will start from C, I can calculate all the joints sequentially. So let's start and solve the problem. Here I am showing all the free body diagrams of my points, and when I will take the joint C, this is the joint C value. We have joint C is here, and joint C showing that there are two unknown value with the one known force. This is 200 force, and these are the two unknown force, and the angles are 45 degree because all the distance are given, which is equal to 2 meter. Here also it is 2 meter. The height is also given as 2 meter. So now I know that the angle is 45 degree here. This is 200 force. These two are unknowns. When I will write the horizontal force and vertical force balance, I am getting from the vertical force balance, I know that the FDC cos 45, which is in the downward direction, that is why negative, and the 200, which is also in the downward direction. So these two will be 0. It is giving that DC is coming out minus 200 root 2. When I will make the horizontal force balance, my negative, this is my negative direction, as I considered that this is positive, this is negative, upward is positive and downward is negative. So here I am having minus FBC minus FDC cos sine 45 or cos 45, doesn't matter. When I will put the DC value as minus 200 root 2, I am finally getting a value which is coming out plus 200. So I know that this DC force will be of compressive nature and force BC will be of tensile nature. But as I said, we are not going to change our sign in between the problem. Finally, when we will put all the forces together, that time we will comment that which force is positive and which force is negative. So once I will calculate the C joint, now I have choice to move here or here. If I will go to joint D, I can see here that DC will be known to me because I have calculated DC, but except the DC, these three are unknown values, so I cannot move to joint D because I can take a joint where maximum two unknowns. When I will move to joint B, BC is calculated here, so only two unknowns FAD and VD, so I can solve the joint B. So let's make this free body diagram of joint B. Here I am having a downward force of 100 Newton. This is joint B. Two forces, one is along BC, one is along BA. And I am taking all the forces away from my joint, means the tensile nature. When I will solve the horizontal and vertical force balance, I am getting that the AB will be balanced by BC, and that will be 200, and these two forces are going in the downward direction. So when I will write the equation that minus BD minus 100 will be 0, so ultimately my BD will be minus 100. So now solving the joint B, I have calculated these two unknown forces. Here you can see that this is my free body diagram. So I have calculated DC and BD. So now if I will move to joint D, that means I know the DC force, I know the BC force, I will be able to calculate these two unknown. So let's make the free body diagram of joint D. So now this is the free body diagram of my joint D. Here we can see that this is a 60 degree, this is force DC, which is minus 200 root 3, this is force BD, which is minus 100, force AD and force ED are unknown to me, and I am taking all the forces away from the joint. However, the negative sign is there because these actual forces are of compressive nature. When I will write the equation of horizontal and vertical forces, I will calculate that my AD is coming out 300 root 2 and my ED is coming out 450 Newton. So now these two I have already calculated. If I'll see here that this is known to me, this is known to me. Actually in the question the forces are calculated for CD, BC and AD member and all. I have calculated AD is coming out 300 root 2, CD is coming out minus 200 root 2 and BC is coming out minus 100. So if it has been asked to find the reaction, we can also calculate the reaction. Here I am showing that how to calculate the reaction. I am showing that this is my truss, and as these two joints are my pin joint, I am assuming two reaction here. these are my forces, and when we calculate the reaction we don't consider the internal forces, we consider the whole truss as a single body. And when I will take horizontal force balance, vertical force balance as well as the moment balance, I will be able to calculate the reaction of the different joint. And we can see here that I am calculating that EX and AX are coming 440 and 380, and you can cross check when I solve these joint. If I'll take these joint, that EX should be balanced with the force in this member, which is this one, and the forces in ED is coming here as 440, and I can see here that the reaction is also coming 440. That means when I started from here and I calculated a force in this diagram, and when I started from the joint or when we calculated the reaction, both the values are matching, that means the solution is correct. So in that way we have calculated all the forces. Some of the forces are negative, that means that it will be of negative nature, means the compressive force. So if I'll go and I'll make the actual force on my trusses, the DC force, this is my DC force, and actually it is magnitude 220√2, but the negative sign made the nature of the force will be compressive. Compressive means this way. This is my force of nature 200√2, and it is of compressive nature. Similarly, the force BD is coming out -100. -100 means again it will be of compressive nature, and it is 100. The force is of compressive nature. The force in AD is coming out 300√3. AD is this one, and it is of tensile nature because the sign is positive here. That means I am going to make the joint away. This will be the direction of the internal forces, and this is of tensile nature. Similarly, I have calculated ED. ED is coming out 440. ED is coming out 440. That means it is also of tensile nature, so this will be the direction of my force. Similarly, I can draw forces on the truss, and I can calculate different forces in the trusses. Thank you.